So, Cramer's rule, there are certain things that happen, okay? But before we talk about that, we're going to go over system stuff, all right? So if you have a system and we put it in the calculator and we get a picture of a graph, okay? And when I graph it on the screen, it shows something that looks like this, right? What is that spot right there? The intersection. That means there's one answer, right? Where that intersection is. So, how do I classify that type of system? That means, is it consistent, consistent dependent, consistent independent, inconsistent? Consistent what? Independent. All right, so this one is consistent independent. It's consistent independent. Okay? Or in my calculator, I could see this. What happens when I see that? Okay, consistent dependent. And how many solutions are there if this happens? Infinite. Okay. Now this one had one? Yes. Okay. What if it looks like this? It's inconsistent. Alright. Those should have been on note cards. So here's how this works with Cramer's rule. Okay, here's how it works with Cramer's rule. And, okay. If D does not equal 0, D means the determinant, then this. It's consistent independent, and it's got one solution. Alright? If your determinant equals 0, and at least one numerator is 0, then we get this one. What happened to that arrow there? Then we get that one. Last one, if D equals 0 and neither is 0, then we get that one. Does that make any sense to you whatsoever? Numerator? What do I mean by numerator? When you divide the number on top.
The last one, if neither is 0?
There's two of them. If one of them is not 0.
Could you show us examples of them?
Strangely enough, yes.
Alright.
I bet that's what I'm going to do on 9, 10, 11, 12. Okay? Alright. So, Cramer's rule is another way to solve a system. We have graphing, we have substitution, we have elimination, we're going to have Cramer's rule, and tomorrow we're going to have your new favorite way, called put it in the calculator. Okay? Alright. So, number 9. I got 3x plus y equals -4. 2x minus 4y equals 9. Okay, so in this thing, or in these rules over here, it says if D. D is the determinant of your coefficient matrix. Okay? So when you have a system, the first thing you're going to do is you're going to find the determinant of the coefficient matrix. Alright? So, I guess let's write it up here. So we're going to find the determinant of 3, 1, 2, -4. Those are my coefficients. So we go down then up. 3 times negative 4. Negative 12. Minus 2 times 1. 2. So what's my determinant? Negative 14. Okay, negative 14. This is your denominator. Okay, that's your denominator. Which means we're going to have to divide. Okay? So you're going to replace what you're looking for. Replace what you're looking for. So I'm going to look for x, or I'm going to solve for x first. Okay? I'm going to solve for x first. So I have x. Okay? This is what I replace stuff with, your constants. Okay, we're going to replace our coefficients of x with the constants. So to find x, I'm going to take the determinant of negative 4 and 9. That's where my x's were. And I have 1 and negative 4. Your y coefficient stayed the same. Okay? So we're going down then up. So I have negative 16, positive 16, minus 9. So what do we get? 7. That's your numerator. So I'm going to do 7 over negative 14. And what do I get? Negative 1/2. That's your x value. So that's the x part of the solution. Okay? Then I got to find y. So we're looking for y. I'm going to leave my x coefficients alone. So I got 3 and 2. We're looking for y, so my coefficients are going to go in here for y. And then we multiply. So I got 27 minus negative 8, 35, over 14, which reduces to what? Negative 5/2. So the solution to your system, negative 1/2, negative 5/2. None of these are going to go to 0. Okay. I don't have any on there that go to 0 for the determinant. So what that means, what these mean here, since I don't have one on the notes that does what I want it to. If I have, let's see if I can make one up. If this doesn't work, I blame y'all. It's going to give me negative 20, positive 20. Okay, we're going to try that and see if it works. So I want to find the determinant of this, okay? Determinant of the coefficient matrix first. So I have a negative 4, negative 10, negative 2, and 5. Okay, so down first. So negative 20 minus 20. Dang it. Gives me negative 40. This 2 just became positive. Okay? Then it'll work. So, there. Now we got 0. Okay, now we get 0. So then I have, if D equals 0, and at least one numerator is 0. So that means that it could be all real numbers, but if neither is 0, then they're parallel. Okay? So what I need to do then is I still need to go in and find the determinant for x and y. Okay? So we'll find the determinant for x. So what am I going to replace then? If I'm looking for x, who gets replaced? Negative 4 and 2. So we're going to replace them with 8 and 16. Okay? So 8, 16, negative 10, 5. Alright? So I get 40 minus negative 160, which is 200. Okay. Now, did I answer one of these questions by finding 200? No. Why not?
Because neither one of them is 0, so that can't determine anything yet.
Right. We've figured out that neither one of them is 0, but still one of them could be 0.
Yeah.
Alright, so then we have to find the other one. So then we have y. So I'm looking for y, so my x's don't change. So I have negative 64 minus 16, and we get negative 80. So what does that tell you?
It's inconsistent.
It's inconsistent. Okay, so here's the discussion that we have. Tell me where you're messed up, if you are messed up, between what it says up here and what happened down here. You think you understand what's happening? Okay, so how about this? What if I had found x and x had been 0, then what?
They're constant dependent. They're consistent.
They're consistent dependent. Do I need to find the other one?
No.
Nope. Okay, so I ended up with 200, and then this one was 0. Then what?
Consistent dependent.
Consistent dependent. Mass confusion, are we good? Good? Good-ish. That's okay.